In the previous episode, Claire and Mary created representations of a student rotating. In this episode, they will measure the angles they have created in these drawings to approximate how many degrees the student rotated in the animations. This angle is called the angle of rotation. They have begun by copying the first angle onto a larger sheet of paper and by estimating the angle measure as 91 degrees. They now watch the applet again to check their work.
Where did the foot begin? There. We just watched the foot. That's it, yeah.
I think it's like 90.
Oh, yeah, 90, yeah.
Or a little
Because
bit
the
more.
foot is the
Yeah.
foot's the key point.
Uh-huh.
So I think if anything, it'll be closer to under.
Yeah.
So about 9.
About 89.
89. 89.
Let's tape this down.
Yeah, tape it, yeah, because we can't. There.
And then on the other edge. This tape is so pretty.
How would we... This kind of looks like it could be almost a third, you know?
Yeah. Wait, to me, it looks like just a little bit over a third.
Yeah, a little over a third. So
Oh no, the other tape fell off.
it's okay. It'll stay. As long as we have one piece of tape, it'll be fine.
There you go.
Just over a third.
Yeah.
1/3 turn.
Mm-hmm.
So are you transferring your angles using the patty paper to the big paper?
Yeah. And on this one, we drew it on the paper, but now we're just taping it down. 'cause
It
it's so
took
noisy.
a little too long.
Yeah. Oh, that's perfect.
There we go. Ugh, this still does not look like an angle to me.
I'm
looks
measuring the
wrong.
outside of it.
It looks so wrong. Anyways, the 45.
Oh, yeah. Oh, it is weird. We have to measure.
So this is
Wait.
where we said this was where like the flat edge was. So 270 plus 145 is 305. What's half of?
What's half of what?
305
Divided by 2.
plus 22.5.
305 plus 22.5 is
327.5. Yeah. Because I think that looks about halfway, right?
Yeah.
The students made a small error when adding here. 270 plus 45 plus 22.5 is 337.5, not 327.5. However, their basic reasoning is correct.
Okay.
There we go.
How would we label this?
Can I see the drawing? That is over, not just over, it's like way over 2/3 of the way.
Oh, wait. It would be, wait.
Wait.
How would you,
One.
so these are eighths. So if you divided eighths, 16ths?
16ths? Yeah. Wait, would it be 15 16ths?
15/16 of a turn. Does that work?
How could you check that? Like could you use your eighths?
We draw more lines.
Draw orange.
Like if we split all of these in half.
Oh, yeah, let's split them all in half. Soon we're going to have just 365 lines on there.
Yeah.
We'll just make a homemade protractor.
Would you consider what you're making right now to be a protractor?
Yeah.
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 Kind of. Yeah.
You know, it's a better protractor than the ones that I've had because they all have like that straight edge.
Yeah, and then it's like,
You can't measure past 180.
yeah, I think it's kind of like a protractor. It's obviously not perfect, but
Are all of them
I tried
split?
to make it perfect, so.
All of them
it
are
should be
split,
pretty
right? I'm
close.
not missing anything?
Yeah, they're all
Okay.
split. So now
1,
each of those,
2, 3,
what's
4,
45
5,
divided by
6,
2 is
7, 8, 9, 10,
22.5. So each of those
14,
is
15,
20
16.
22.5 degrees each, okay?
Mary and Claire have subdivided their protractor so that they can measure the angle more accurately. They have taken each piece that corresponds to 1/8 of a full turn, or 45 degrees, and divided it in half. This means each new piece corresponds to 22.5 degrees, or 1/16 of a full turn. Mary mentioned that if they subdivided the circle so that there were 360 pieces, they would have created a regular protractor. You may be more familiar with a protractor with a straight side, the kind Claire mentioned. To make these protractors, you take a semicircle, or half turn, and divide it into 180 slices so that each slice is a 1-degree angle. Equivalently, you can create a protractor by dividing a whole circle or full turn into 360 slices. This also creates 1-degree angles. As Claire mentioned, this type of protractor allows you to easily measure angles that are larger than 180 degrees.
Maybe you could talk me through, give me a rundown of rotation 1, what
Okay.
your approximation is, rotation 2,
So-
rotation 3.
Rotation 1, we think our estimation is
Like just under
just
90.
under 90 degrees.
Yeah.
Like, because with our,
Well, because I think even the drawing was
Protractor,
off. Because
yeah.
you assumed it was 90.
yeah, but it's a little bit off. And
Yeah.
so, but with our protractor, it's like 90 degrees exactly, but also our drawing was a little bit off. So we're just approximating that's a little bit below 90. And then for our second one, we used the 45 degrees. We could probably remeasure it with the,
Yeah.
so
Yeah, and see, it was just
look, it's,
yeah, it was just over.
just
So we added an extra
tiny.
10 degrees to
Yeah.
135.
so it's, so we approximated about 145 for that one using our homemade protractor. And then for this one, this is the one that we added more lines to our protractor because we approximated it to be 15/16. And so we're like, wait, we can just cut it into more.
Yeah.
Cut it in half and make it 16, and we could see it perfectly. And to us, it looks like it's perfectly like 15,
Yeah.
16.
Aside from me not being ruler accurate, but like, and like
And my
the
drawing a little
center
bit
of the protractor is kind of like. So to me, when I'm like seeing all of these, the corners of all of these is where the person is, and then so they're kind of like just full blown scales of the turn itself instead. Whereas this is like the whole potential 360 degrees that they could turn with them at the center. So, like this on the protractor, the center would be where the person is, and so then we line up the
see.
center with where the legs join, so that
we can
that's
see the
where
angle.
the person is turning.
I see.
So they're kind of just like blown up scale models of like the turn itself
Yeah.
instead of
just like a little guy.
the start and end.
I see. Blown up. That's a good, yeah. So, yeah, that's a good way to put it. You're sort of imagining it getting, like, larger proportionally.
Yeah, like you're zooming in.
Yeah.
Yeah, that makes sense.
In this episode, the students measured the rotations they drew in episode 1. They estimated rotation 1 was 1/4 of a turn, rotation 2 was 1/3 of a turn, and rotation 3 was 15/16 of a turn. They used a protractor divided into eighths, where each eighth was equivalent to 45 degrees. They also subdivided the eighths to estimate 16ths, which would be half of 45 degrees or 22.5 degrees. In the next episode, the students will explore how to measure these rotations in terms of GIPS.